Hello students, in this video we'll use the formal definition of limit to prove that the limit of a linear function exists. Let's recall that we write the formal definition, the limit as x approaches c of f of x is equal to L if and only if for every epsilon greater than 0 there's a delta such that what? Such that 0 less than x minus c less than an absolute value less than delta implies that f of x minus L is less than epsilon. That's the formal definition of what it means for a limit to exist. Notice that I cannot have x equals c in the definition because x minus c in absolute value is greater than 0. So that's the condition that x cannot be equal to c in the formal definition of a limit. So let's see an example of how we do something like this. Example, let's show that the limit as x approaches 3 of 6x plus 5, well, we should have a good sense of what this is going to be equal to because I know that the limit as x goes to 3, x should just be 3. So I think this should be what? This should be 3 times 6, which is 18. 18 plus 5 is 23, right? So I claim that this limit is equal to 23, which should make intuitive sense just by plugging it in. So let's prove that. So here's how the formal proof structure goes. I'm going to let epsilon be greater than 0. And I need to find a delta, right? And so what I'm going to do is I know what the answer is. So I'm going to choose the delta and I'll explain how I got it. Let's pick, and so here's the picking process, pick delta to be what? To be epsilon over 6. Epsilon over 6, okay? And so now let's suppose, I want to show that if x is that close to 3, so suppose that 0 less than x minus 3 less than delta. Then what can we say? So we're going to assume this is true now. And then what can be said? Well, let's look at our function. Our f of x is 6x plus 5, then minus 23. Well, 5 minus 23 is going to be what? It's going to be negative 18. So this is going to be a 6x minus 18. Now, those both have a common factor of 6. I'm going to pull that 6 out of the absolute value. Then I have 6, and then I have x minus what? X minus 3 is left. And lo and behold, I have now the x minus 3, which I know by assumption is less than delta. So by my assumption, x minus 3 in absolute value is less than delta. So this is less than 6 times delta. But I chose delta to be epsilon over 6. So this is going to be 6 times epsilon over 6, which is just equal to epsilon. So I've shown that if 0 less than absolute value of x minus 3 less than delta, then my function, f of x, minus my limit over here is less than what? Is less than epsilon. So that proves formally that that limit is equal to 23. Now, how did I pick this delta equals epsilon over 6? It was not just a contrived thing. I sort of did some side work in the back of my mind. What I said from the start of this problem is I said, okay, what do I want? I wanted that my function, which was 6x plus 5 minus 23, I wanted my function that in absolute value to be less than epsilon. And so I said, oh, well, what this is 6x minus 18. I want that to be less than epsilon. But what I really want is, if I can divide it by 6 now, I could say I really want x minus 3 to be less than epsilon over 6. And x minus 3 was exactly the thing that we had control over. We have control over the difference of x and 3. So I said, oh, if this is true, if my delta happens to be epsilon over 6, then this calculation will be able to reverse itself and I'll get exactly what I want. So in the back of my mind, I'm doing some side calculations to figure out that delta. So when you're doing these problems, it's always good to write down what you want to find out what delta needs to be and then choose that particular delta in your formal proof. Thank you very much.